Hello students, now we are going to learn how to do experiment using trainer kit. Okay, first we'll see what are the components in the trainer kit. Okay, so first one, this is the power supply, right? Okay, so here you can observe the LEDs. These are output indicators, right? Okay, so these are the conversion used for BCD to decimal, 7 segment display, right? And TTL clocks. Okay, if you want to use clock for any experiments, you can use this. And also monopoles, right? Okay, so here you can see, okay, these are all called as sockets, right, where you fix ICs in this. Okay, so in these sockets we are fixing ICs. Okay, so here you can see there are 16 pin IC you can fix here. Okay, so if it is 14 pin IC, either you can make use of upper 14 pins or lower 14 pins. Okay, so wherever you come across red, okay, so those are all called VCC connection. Okay, then black color indicates these are all ground connection. Okay, so and down here you can see these are input side. Okay, so whenever you want to give one input, you set that input to high. Okay, you can see LED is on. Okay, if input is off, just you make it as 0. Okay, so this switch is called as what? Toggle switch. Okay, so where you can provide input whether 0 or 1. 0 means put in off state, 1 means just make it is high. Okay, this is on state. Okay, so this is power supply. Okay, if you want to provide any external power supply, you can make use of this supply from the trainer kit. Okay, and this is continuity check. Okay, so here you can see these are called as patch cords. Okay, so this is nothing but a wire where you can use for connection purpose. Okay, so before doing connection, you have to see whether this patch cord is correct or not. Okay, how to see? Just hold at both the hands. Okay, if power glows means if this LED is on, this patch cord is fine. Okay, then it is suitable for connection purpose. Okay, else you can change the patch cord. Okay, whichever is in good condition, just make use of that patch cord for connection purpose. Okay, so today we will go with the code converter experiment. Okay, so the IC used for code converter is XOR gate, right? Okay, so as I told, the IC number is what? 7406. Okay, you can see at the last line. Okay, you can observe, right? 74 followed by some characters 86. Okay, just you ignore characters. Okay, IC number is here is nothing but 7486. Okay, so available sockets. Okay, you can make use of any sockets. Okay, any socket is fine. Just if you see the IC, okay, in the top of the IC there is a mark, right? Okay, so that should come upward. Okay, here you can see the mark. Okay, sometimes U shape will be there. If not U shape, bubble will be there. Okay, so that should come upward. Okay, so just you fix in socket. Okay, so just you press this. Okay, so it is lock. Okay, if you open this, it is in unlock position. If you do like this, now IC is locked. Okay, as I told, 7486 is what? 14 pin XOR gate IC. Okay, so either you can make use of first 14 pin or second 14 pin. Okay, because total is 16. Okay, so out of 16 we are just using what? 14 pin. Okay, so if you see here, last two pins are empty, right? Okay, so last two are empty, means we are not using these two pins for connection. Okay, so we are ending only till here. Okay, so 1 to 7. Okay, since we are not using these two, this pin becomes pin number 8. Okay, so while doing connection, this is 8, 9, 10, 11, 12, 13, 14. Okay, like that. Okay, so instead of this, if you are using last 14, means if you see here, first two pins are empty. Okay, means pin number 1 starts from here now. 1, 2, 3 up to here 14. Okay, in this condition we are not using these two pins. Okay, so whichever is comfortable, you can make use of that IC. Okay, so for time being I am using first 14, leaving these two unused. Okay, after 7, 8 to 14, it continues like this. Okay, so as I told, this is XOR gate, right? Okay, so before doing any connection of the experiment, first check whether the IC is working properly or not. Means we have to now verify truth table of XOR gate. Okay, so before doing connection, first we have to connect VCC and ground first. Okay, so pin number 7 is ground. Okay, here you can see this is pin number 7. Connect that to ground. Okay, so wherever black color is there, right? Okay, so all those represent ground connection. Okay, and red represent VCC. Okay, since I am leaving these two unused, now this is pin number 8, right? 8, 9, 10, 11, 12, 13, 14. Okay, so 14 is VCC. Okay, so first you have to connect ground and VCC connection, right? Okay, before doing your experiment connection, first check whether these gates of the ICs are working or not. Okay, so as I told, pin number 1 is what? Input. Okay, so these are input side. Okay, you can make use of any pin. Okay, so either this. Okay, so it is left to you. You can make use of any pin, right? Okay, and also pin number 2 is second input, right? And pin number 3 is output. Okay, so at output side you make use of any pin, right? Okay, so it is left to the student. Okay, so all are working fine. Okay, you can make use of any output indicator, right? Okay, so 1 and 2 are input. You can see it is connected at input side. Okay, so pin number 3 is output. It is connected at output side. Okay, so now check whether gate 1 is working correctly or not. Okay, so how to check? Here you have to give the combination. Okay, so 0 0 means output is 0. Okay, so we are checking truth table of XOR gate. Okay, 0 0, output is 0, right? Okay, 0 1. Okay, so 0 1 combination, output is 1, right? Okay, so next combination is 1 0, output is 1, 1 1, output is 0. Means what? First gate is correct, right? Means first gate is working correct. In code converter we are making use of 3 gates, right? Okay, as I told, one IC contains 4 gate. Okay, so in this experiment, out of 4 gate we are using 3 gates. Okay, so we have to now check other 2 gates. Okay, so just use the same patch cord. Okay, we know that pin number 6 is output, pin number 4 and 5 are inputs. Okay, so again repeat the process. 0 0 means 0, 0 1 1, 1 0 1, 1 1 0. Okay, so next check for third gate. Okay, so in third gate 8 is the output, right? Okay, if this is the 7, this is 8, pin number 8 output, right? Okay, 9 and 10 are input. Okay, so repeat the process. 0 0 0, 0 1 1, 1 0, 1 1 1 0. Okay, so now all the gates are working fine. Okay, so you can check for fourth gate also. Okay, anyway we need only 3 gates. I verified for 3 gates. Okay, so now what I have to do? We have to do the connection for binary to gray and gray to binary. Okay, so connection is done by looking at the circuit diagram. Okay, so if you see, right? Okay, so binary to gray means what? We have 4 inputs. Okay, so you connect 4 patch cord. Okay, B0, let it be B0, second one is B1, right? Okay, so B2, right? B3. Okay, so we have 4 inputs. Okay, so binary input. Okay, since this is input side. Okay, so we have 4 bit. Let it be B0, B1, B2, B3, right? Okay, so now we have to connect these to XOR gate. Okay, so output from XOR we have to connect at output side. Okay, so what is First one, B0 is connected to so if you look at circuit diagram, so B3 is connected to G3, right? Okay, so you just see the circuit diagram. B3 is connected to G3. Okay, so B0, B1, B2, B3. Okay, so this is B3. Okay, we are converting from binary to gray. This is B3. B3 is connected to G3. G3 is what? Output. Okay, directly you can connect this to output side. Okay, so what is second circuit? Second gate diagram from B2, right? Okay, so you have to connect that to what? Pin number 1 of XOR gate. Okay, so this is B3, this is B2. Okay, so we have to connect first from B3 connect to pin number 1. Okay, so from the B3 you have two connection, right? One for G3. Okay, directly we have connected. Okay, since we have one more connection just from the same point. Okay, so from same point you connect to pin number 1. Okay, so from B3 two connection, one directly to G3, another to pin number 1. Okay, so second one is what? From B2 you have to connect that to pin number 2. Okay, so first gate inputs over, right? Okay, so output of first gate means that is from pin number 3, right? Okay, so you have to connect that to G2. Okay, so G2 means here. Okay, so 3 is output of first XOR gate. Okay, you connect that to G2. Okay, so next we'll do connection for next XOR gate. Okay, so that is for second XOR gate inputs are from B2 and B1. Okay, B2 and B1. Okay, so just take one more patch card. Okay, from B2. Okay, from B2 pin number 4. Okay, and B1 what? Pin number 5. Okay, so these two inputs output from second XOR, that is pin number 6. Okay, so you have to give it as B3. Okay, binary to gray, G3, G2, this is G1. Okay, so next last connection for XOR gate. Okay, for last XOR gate inputs from B1 and B0. Okay, so this is B1. Okay, from B1 one more input, so 8 is output, right? So give it to 9. Okay, so another input from B0. Okay, so outputs are from pin number 8 to what? G0. Okay, so now connection is over. Okay, you can see binary inputs, gray output. Okay, so this is B0, B1, B2, B3. Okay, gray output G0, G1, G2, G3. Okay, so now we have to verify the truth table. Okay, so we have to verify all 16 combination. So first combination is what? 0 0 0 0 0 0. Okay, so we are getting 0 0 0 0. Okay, so for 0 0 0 1 we are getting 0 0 0 1. So just verify for all 16 combination. Okay, so here 0 is nothing but toggle switch should be off, 1 means on the toggle switch. Okay, next combination 0 0 1 0. Okay, so what we are getting? 0 0 1 1, like that. Okay, for 0 0 1 1. Okay, 0 0 1 0, like that. You have to verify for all 16 combination. 0 1 0 0. So what we are getting? 0 1 1 0, correct. Okay, Next combination 0 1 0 1 means 5. We are getting 0 1 1 1. Okay, so next 6 0 1 1 0. Okay, so we are getting 0 1 0 1. Yes, correct. Next 7 0 1 1 1. Okay, so we are getting 0 1 0 0. Okay, next 8. 8 means 1 0 0 0. 1 0 0 0 means 8. Okay, for 8 we are getting 1 1 0 0. Okay, so just observe the truth table. You have to verify the truth table. 9 means 1 0 0 1. Okay, for 9 1 1 0 1. Okay, 10. 10 means 1 0 1 0. Okay, so here all bits are high. Okay, you can check with truth table. For 1 0 1 0 we are getting all bits as high. Okay, so next after 10 11 means 1 0 1 1 1 1 1 0. Okay, so next 12. 12 means 1 1 0 0. Okay, so we are getting 1 0 1 0. Next 13 1 1 0 1. We are getting 1 0 1 1. Okay, so for if all the bits are high, okay, if all the bits are high, we are getting 1 0 0. Okay, so this is how we checked for all 16 combination. Okay, so we provided binary input, so here we observed the binary output. Okay, so this is B0 B1 B2 B3. Okay, so G0 G1 G2 G3. Okay, so thank you.